If you turn this video at one point off, then please tell me the reason for it so that I can improve. Otherwise, I'm welcome. I'm trying to learn Heliology, today Protostars, and after we've done that, we're going to do arm strength training. And if you participate in the arm strength training, that is video. Protostars, young stellar objects. Everything has a prelude, even stars, so something happening before they were born, basically. They are born from vast patches of interstellar fog, light years across, known as giant molecular clouds, which we met briefly in chapter 1. Okay. They are vast patches of interstellar fog, so a gigantic area of fog. And these are giant molecular clouds. To recap, these nebula are very patchy, with some regions denser than others. A denser neighborhood, by virtue of its higher gravity, pulls in material from its surroundings and grows denser still. So it's a very big area with a lot of nebula in it, fog, whatever. And in some regions it is denser. And because it's dense and there is something, it pulls more to it. Has a higher gravity, it pulls even more to it. Pulls material from its surroundings and grows even more denser because it puts more and more in. This increases its gravity even further, which in turn allows it to grow bigger and faster. So the faster it eats, the faster it gets, the bigger and bigger it gets, and the stronger it can eat. At the same time, rotation within the growing cloud fragment causes it to flatten out. For some reason that thing is rotating. Why is that thing rotating? So because it is rotating, it's flattening, it's getting flat. So it pulls all together, but it gets also flat. The result, around 1 million years later, is a gigantic dusty shell called a globule. I don't really know multiple of these words, but basically we're saying that the thing pulls more and more to it and becomes a globule. This is a shell, I don't get it. At the center of this cocoa, I know this is what butterflies use. At the center of this cocoa is a warming, gaseous clump about the size of the current orbit of Mercury, known as a protostar. Okay, in the middle is a big amount of gas, a gas clump. And that whole thing is as big as the orbit of Mercury, so very big. That is much bigger than the Sun. Mercury goes around the Sun, so it's much bigger than the Sun. As its name suggests, a protostar is not yet a true star, while the letter, so that is former letter. Former means the first one and letter means the second one. While the letter is driven by nuclear reactions, so a star has nuclear reactions in it, a protostar is powered only by gravitational contraction. Okay, protostar is contracting altogether, and for some reason that makes it to turn somehow. And it has a lot of gas there, and the thing is very, very big, much bigger than a star. To understand this process, picture a dam full of water. Contained, the water has gravitational potential, energy that it has by virtue of its influence under Earth's gravity. If the dam bursts, the water gushes out and its potential is unleashed is kinetic energy or energy of motion. In the same way, a protostar is full of potential energy. As it falls in on itself under gravity, its potential energy decreases while its kinetic energy in the form of heat rises. The contracting protostar gets warmer and warmer. Why does it get warmer? Because it pushes itself together? But we know that the thing is very big, but not that big. It was here 1 light year across. 1 light year across, that is big. We have to think, we're talking not about light, so massless photons traveling. We're talking now about material, gas and fog, or whatever. A sun exists out of matter, out of material. And it is falling into, because it gets a more stronger gravity. Somehow it gets warmer, the potential energy gets less because it already had accumulated it all together, but the kinetic energy rises because, in the form of heat, because it gets warmer and warmer. The protostar stage does not last long. After about 100,000 years, the object becomes warm enough for the heat it generates to start to vaporize its birth core. Somehow the birth core vaporizes. So the center in the middle, it was the gaseous clump. So the gas in the middle gets warm and vaporizes. Gradually, it unveils itself to the universe as a huge luminous mass, glowing like a dull red ember. I don't know what ember is. Now the gas in the middle gets warmer and warmer, and the thing is not burning but glowing, or whatever, maybe more. Why does it get more warm? That is the important thing. I don't think they've written it here. It gets warmer and warmer, and the gas in the middle, the gas clump core, starts to glow. The gravitational contraction continues until around 1 million years later. The protostar's core temperature nears 5 million degrees Celsius. Yes, it gets very, very hot in there. At this prelude to the stellar object's life, as this prelude to the stellar object's life, as a true star draws to a close, it is set to enter a period of turmoil. Gradually, it unveils itself to the universe as a huge luminous mass glowing like a dull red ember. If we could peer inside the dark, core that surrounds the typical protostar, we might see something like this. The protostar glowing red may be flattened out by rapid rotation. It is glowing red, but it has rapid rotation. That's how I think. Why is it rotating, and why is it getting warmer? It is still surrounded by a vast disk of gas and dust, around which planets will one day form. Okay, we've read it, and we got some surrounding information, and we could centralize 2 specific questions. Why does it get warmer, and why is it rotating? But we got more surrounding information, more context, so if we get more answers and more things in helioscience, we will understand more about the sun. That was the helioscience part, or heliology. If you prefer heliology, you can go directly to the next part of heliology. If you stay here and participate in the arm strength training, that is better at your own risk. We have the next thing short of the further part, and we're breathing in and reaching with the fingertips as far to the sides as you can. And get down. Reach as far as you can. The hydrotower. And now the flail. The fists, circle the arms up and around, and turn the whole time the wrists. If any of these exercises causes pain, then don't do it. The other way around, circle the other way around. And the mise en masse, you don't need the arms to the side, circle them in front, backwards. Okay, now the arms together, and we're doing the star. The fingertips together and press together. Have a little bend in the elbow. If there's at any time pain at the wrists, then stop immediately. And also if there's pain at the fingers, then stop and don't do it. And now the prow. The fingertips together. Again, a little bend in the elbows. And if there's at any time pain at the wrists, or in particular at the fingers, then stop. And the next exercise. Now, press with these 4 fingers into the thenar and hypophylar of the hand. And keep slowly in with the hand. Again, if there's at any time pain at the wrists or fingers, then stop by pain at all. And on the other side, press, give slowly. And on the other side, press, give slowly. And again, press, give slowly. And again, press, give slowly. Last time, press, give slowly. And now the other way around. Okay. Press from bottom. Press. On the other side. Press. And again, press. And last time. Now arm long out. And press. And now give slowly. And again with the other arm. Press. Slowly. And again. And one more time. Press. And give slowly. And now, both push-ups. Let's do 20. 20. Hands underneath the shoulders and tuck the tailbone in and go down, elbows close to the first one, and the second one, and the third one. And number 4, and 5, and 6, and 7, and 9, and 10, and 12, and 13, and number 14. And we're coming to the end with 15 and 16 and 19, and now let's do the last one, number 20. And now the mise en place again. Arms to the side and circle them in front. And backwards. Feet a bit more together and make a big forward bend. And outside front. And now the elephant trunk, one arm in front, shoulders back, down, pull the arm in, have flat fingers, try to relax the arm, turn the palm up to the sky. And the other arm in front, shoulder back and down, pull the arm in, have flat fingers, try to relax the arm, cover the back of the shoulder, turn the palm up to the sky. And now the floor, go with moderate effort over the middle part of the lower arm. And on the other side. And that was the arm strength training. I thank you very much, and it makes it.